Hello, welcome to the workshop. As you can see, today in the workshop, we are going to deal with a multivibrator circuit. And a multivibrator circuit is a transistor circuit that causes the transistor to be switched on alternately so that the lead will be actually switching off and off alternately. As you can see, this is just the circuit diagram as the theory part is giving you an explanation of how a multivibrator circuit work. Now you can see the diagrams of the component in the circuit here. As you can see, you have a transistor here, transistor 1 and transistor 2 here. We also have the lead, two lead that will be switching off alternately. It is an automatic operation. This time we do not need a manual switch off and switch on. We'll be using a button to switch or to latch the circuit on and off. But this is a multivibrator circuit. You do not need to do that. It is an automatic function. You will see both lead will be switching on and off alternately without manually operated. Now, as you can see, we also have about 5 resistor here. You have 100 ohms resistor. This 100 ohm resistor is just there to input a control voltage into this circuit purposely. And we have 47 kilo ohms here. It's also there to actually control the amount of voltage that will be input to these two 10K transistor which are connected to the base. Now this 10K resistor here are there to input certain amount of current or voltage into the circuit so that the transistor will be switched on. It's like they are creating a tog, and what is actually making the difference, it will be the capacitor, because the capacitors are actually charging and discharging automatically in the circuit as both transistors will be switching on and off. So that will make the resistance difference. Actually, the resistance will be increased and then decreases. That will cause the lead or the transistors to be switching on and off alternately. Now, how this operates. Now, you have a transistor here. You know that this is the base of the transistor, this is the collector, and this is the emitter terminal of the transistor. Now, it's like the base is connected to the collector. So the moment you input a voltage here, automatically the voltage flow to ground, flow to the emitter to ground. The voltage that is here will not flow from the collector to the emitter unless there is a base voltage or unless the resistance between the collector emitter junctions of the transistor is being reduced. You know that the base voltage is inversely proportional to the resistance between the collector and the emitter junction of the transistor. This simply means as the base voltage increases, the resistance between the collector emitter junction will decrease. As the base voltage decrease, the resistance of the transistor will increase. Now, when you input a voltage here, automatically it go to the emitter. Now it's like the emitter, it's like the base and the emitter are connected together. That is how the transistor look like. Now we have a capacitor here. The capacitor is connected from this point, from the emitter of the T1, and then the negative lead of the capacitor is connected to the base of T2. The same goes for T1, where a capacitor positive is connected to the collector of the transistor T2, and then the negative terminal of the capacitor is connected to the base of transistor T1. Now, when you power the circuit, don't forget that this circuit will be powered by 5-volt DC using USB charger, a phone charger. You can use this to power this circuit, especially like techno chargers and other charger that are good, have high current. So you can see here, this is the lead. You will be seeing it switching on and off alternately, as I said before. Now, when you power the whole circuit here using 5-volt DC, the voltage is coming into here, into this point. Now, if this voltage is being applied to T1 here, T1 resistance will be decreased, and then a voltage is now going this way. Therefore, the resistance here is now what? Decrease. It's like you are connecting this path to this path, so that voltage will now move through this point. Now, when a voltage is moving through this point, there is already a base voltage here. And now we have this capacitor here, meaning when there is a voltage here moving this way, this capacitor is passing the voltage into this particular point. Thereby, also as it is doing that, it is going to be charged. You know that when a capacitor charge, it blocks the DC, the resistance increases. Now, as this transistor is actually passing the voltage, this capacitor here is now connected to ground like this. It's now connected to ground. You see, the capacitor is connected to ground. Know that the base is directly connected to the emitter. That is how it looks like. So it is now a circle like this. You see, it's like the capacitor, this capacitor here is like it is now connected to ground. This is the transistor, because the resistance here has been increased. So this now is just a circle here coming this way. When this happens, actually, this capacitor is going to discharge, because it's like both lead has been connected together. You see, both lead has been connected together. So as this is passing the current here into here, it is charging, and this is discharging. When this is completely charged, it stops to flow a current, or it stop to allow voltage to pass to the base, And when there is no voltage here, this transistor is going to switch off. By then, this capacitor has already been discharged. Since this capacitor has stopped the voltage passing through this point, now the voltage that was actually passing here will now stop to pass, and it will not move because this capacitor has been discharged. Now the voltage will move through this discharged capacitor to this base, and this transistor will be switched on, thereby going to ground, allowing this lead to be switched on. And when the voltage is moving in this direction as well, this voltage that is moving here is charging this capacitor. When this capacitor is charged, it will block the voltage that will come in this way. And when this voltage that is moving here has switched on this transistor, this capacitor here, this lead here is now moving this direction. It's like this is now connected this way to ground. And you know that the capacitor negative is connected to the base, and the base also of this transistor is connected to ground. So it is actually connected. Both leads are actually connected together. When the capacitor is like this, there is a break here. This whole thing is connected. The transistor here is serving as a key to this capacitor. Let's say you have a circuit like this. You have a circuit like this. This is the capacitor. Now this is something like this, something like this, something like this. This is like a transistor. When this transistor, the resistance of these transistors has been decreased, it's like this is switched on. Now the voltage is now passing this way, shorting both terminals. But because of the resistance, this capacitor is going to be discharged slowly. So that is exactly what is happening to those capacitors. As this one is passing the voltage to this base, this one, remember that this capacitor terminal is coming this way, is already connected to this terminal of the emitter of the transistor to the ground. So this is the path. See, coming this way. This is the path coming this way. Now here and here is break. So this is not connected. So when a voltage is moving through this capacitor to the base here, this is being connected. So now you have both leads here connected together. That will cause this capacitor to be discharged. As this is passing the voltage, this also is charging. As this is charging, this is discharging. When this is charging, this is discharging. That is how both capacitors are charging and discharging alternately. As this is charging, this is discharging. As this is charging, this is discharging, because both transistors will be switching off, allowing to shut down both lead of the capacitor together. If the voltage is moving this way, as this transistor is switched on, now the lead of this capacitor will be actually connected together. They are shorting together, but there is a resistance, so it is going to be slowly discharged. So that is exactly how a multivibrator circuit works. Now let's come to the practical aspect, where you will see the physical component and how actually they functions. Now this is actually the diagrams of the multivibrator circuit. This is the power. You use 5 volts DC. USB charger. You'll be using charger, USB charger. This is a mobile charger that you use to power the circuit. This is just 5 volt. Now you can see both lead, you can see the capacitor. The capacitor is connected here to the base, and the negative terminal of this other capacitor is connected to this base. So as this is actually passing the current, the lead of both are actually connected through the resistance. So as this is discharging, this is charging. As this is charging, this is discharging. So that is how a multivibrator operates. Now let me power the circuit so that you will see exactly the action of a multivibrator circuit. The multivibrator circuit have many uses, but this is just the beginning. As we go along, we will be using this circuit to work out various projects in the workshop. Now look the actions of the multivibrator circuit. So this is exactly how a multivibrator circuit works. So as one capacitor is discharging, the other is charging. It is happening alternately on and off. Thank you very much for watching the video. Please don't forget to subscribe. In the next video, we are going to deal with a multivibrator circuit with 3 lead. This is 2 lead, 2 transistor. We are going to deal with another multivibrator circuit that has 3 lead, 3 transistor, 4, 5, so on and so forth. You will see how that one will be actually constructed or will be connected in the circuit. Thank you very much. Thank you once more again.